Here are 5 strange things left behind by lightning strikes. Number 5. Petrified bubbles. When lightning strikes a rock, it can create a fascinating phenomenon, a network of bubbles within the stone. These hollow spheres form as the intense heat of the strike vaporizes elements like water, carbon dioxide, and oxygen trapped within the rock. In 2016, researchers made a significant realization about these stone bubbles. They function as natural thermometers, providing insights into the temperature and duration of heat generated by the lightning strike. This discovery was particularly exciting because lightning, despite its frequent occurrence, is still not fully understood. Any method that enhances our ability to measure its power and behavior is highly valuable. Curious about the mechanics of these thermobubbles, researchers delve into the intricacies when estimating the maximum energy released by a lightning bolt upon striking a rock. They analyze variables such as the composition of the stone and the characteristics of the bubbles, including their size, quantity, and arrangement. By combining these factors, they pinpoint the peak intensity of the lightning strike. Number 4. Perfect crystal balls. Volcanoes' extensively researched geological phenomena have drawn scientific attention for years. Among the discoveries made, one particularly striking find emerged in 2009. Small glass spheres within volcanic ash. While the presence of glass in eruption sites is not unusual, previous instances typically yielded jagged fragments. The revelation of perfectly spherical glass formations was unexpected, but not entirely inexplicable. During volcanic eruptions, the violent expulsion of debris often results in the collision of individual ash particles, generating significant friction. This friction can initiate lightning bolts, which in turn superheat the surrounding air to temperatures reaching 54,000 degrees Fahrenheit, 30,000 degrees Celsius. Under such extreme conditions, glass particles melt into a liquid state. As these molten droplets descend, they gradually solidify into smooth orbs, forming the distinctive glass balls observed by researchers. Number 3. A super rare crystal. In the past, scientists categorized crystalline solids into 2 distinct types. One category, exemplified by substances like table salt and diamonds, featured atoms arranged in a repeating lattice pattern, showcasing perfect order. The other group, represented by materials like glass, lacked such organization, with atoms haphazardly arranged in a chaotic manner. Then emerged quasicrystals, a unique class of solids blending orderliness with disorderliness. These in-between crystals exhibited a structured yet irregular arrangement of atoms. Unlike traditional crystals, their repeating patterns varied, defying conventional crystallographic norms. Initially considered purely theoretical, the existence of quasicrystals was doubted by scientists for years. However, evidence of quasicrystals began to surface at sites of meteor impacts and nuclear detonations, where extreme temperatures, pressures, and shock conditions prevailed. It became apparent that such conditions were also met during lightning strikes. Consequently, researchers turned their attention to fulgurite, formed by the fusion of sand due to electrical discharges, in search of quasicrystals. In 2023, a discovery in Nebraska marked a milestone, the first suspected quasicrystal originating from a lightning strike. This remarkable specimen showcased a seldom-seen symmetry with 12 sides, and its chemical composition was unprecedented in recorded scientific literature. Number 2. Whistlers. Not all remnants left by lightning are tangible objects or physical damage. Among the intriguing alternatives are auditory phenomena such as peculiar whistling noises. These unique sounds are associated with a particular type of lightning known as whistlers. Contrary to the booming thunder typically associated with lightning strikes, whistlers produce a distinctive whistling sound, reminiscent of the pew-pew-pew of a video game. From a technical standpoint, whistlers manifest as bursts of very low frequency, VLF radio energy waves. What's truly astounding is their capacity to travel vast distances across the globe by riding along the Earth's magnetic field lines. For instance, whistlers detected in Dunedin, New Zealand, originated from thunderstorms thousands of miles away off the coasts of Central and North America. In 2008, Dunedin experienced a notable surge in whistler activity, with daily counts skyrocketing from an average of 1,000 to a staggering 15,000. Researchers linked this surge to lightning generated by a volcanic eruption in Alaska's Aleutian Islands. Over a span of just 10 hours, more than 21,000 whistlers were recorded. However, when the ash plume from the volcano collapsed, cutting off the lightning activity, the whistlers abruptly ceased. Number 1. Sky detergent. In 2012, scientists stumbled upon a discovery so improbable that initially they questioned the accuracy of their instrument readings. However, upon closer inspection, it became evident that their tools were functioning perfectly. Leading to a startling revelation, lightning possesses the ability to purify the atmosphere by eliminating harmful pollutants. The investigation commenced when researchers embarked on flights into stormy regions over Colorado, Oklahoma, and Texas, aiming to gather data following each lightning strike. Analysis of the collected data unveiled a significant increase in hydroxyl and hydroperoxyl concentrations following visible lightning events, as well as in proximity to other electrically charged regions within the storms. Initially skeptical of the abundance of these two elements, scientists later confirmed the validity of their findings upon thorough review. This discovery highlighted lightning as one of the Earth's primary generators of hydroxyl, a highly reactive compound renowned for its capacity to neutralize pollutants by chemically binding with them. Unveiling lightning's role in environmental purification represents a promising development for the planet.